Hello, everybody. Good to see you all. I'm Marco Casalaina. I'm VP Products of Azure AI. And today, we're going to share some lessons that our customers have learned and that we have learned in building effective copilots. In a few minutes, my colleagues Jeff and Sindhura are going to join me on stage here, and they are going to show you some of the tools that we have to build these copilots. But first, I was in Germany recently, and in Germany, I got a look at this application called Parloa. Parloa is an always-on copilot for contact center agents. And I have to tell you, it was one of the most amazing things I've ever seen. So I would like to welcome to the stage the CEO of Parloa, Malte Kosub. Malte.
Hi, Marco.
Welcome, Malte.
Nice to meet you.
All right. Let's put this up here and kind of show it. Tell me a little bit about what is Parloa? What's this about? What does this thing do?
Yeah, first of all, thanks for the invitation. Parloa provides AI agents for customer support to automate repetitive tasks, and Parloa also provides copilots to help human customer support agents to real-time translate conversations so they can talk to any customer in the world, no matter what language they speak.
All right, well, that's pretty cool. Now, it's hard to talk about a contact center application without actually having the audio, so let's hear what it actually sounds like in real life.
I see that there is indeed an error in the total amount. I will make the necessary adjustments to the invoice right away and send it to you. May I please have your email address?
Veo que efectivamente hay un error en el importe total. Haré los ajustes necesarios en la factura de inmediato y se la enviaré. ¿Podría darme su dirección de correo electrónico?
Claro, mi correo electrónico es antonio.perez@gmail.com.
Noted.
All right, so let's move on from there. But now, basically, what's happening here is that the agent is only able to speak English in this case.
Yes.
The caller is speaking Spanish, and Parloa is in here translating this thing in real time between them. So that's what the caller hears
Exactly.
is his own language in this case, yeah? All right, that is pretty cool. And this is an always-on copilot for contact center agents. Basically, when they're on the call, this copilot is always there.
Exactly.
So, I mean, you mentioned to me that you're using Azure to build this. What Azure services are you using to make this work?
Yeah, so maybe break it down in different topics. If we talk about listening, we're using the speech-to-text of the cognitive services. We're using Azure AI to fine-tune those models on phone audio quality on our specific use cases to increase the accuracy. For speaking, we are using the text-to-speech of the cognitive services, but also the OpenAI voices. So the voice in the video you saw was an OpenAI voice. We use that via OpenAI on Azure for reasoning and thinking. We have been using GPT-4 Turbo with PTUs. Now we are implementing GPT-4o. We're going to launch that next week in production to all of our clients. Our internal tests and benchmarks showed that it's clearly performing better in all our metrics to GPT-4 Turbo, so very excited about that. When we talk about our infrastructure, we're using Azure Kubernetes services, Azure Container Registry, and a lot of other services. We built our own agent framework, which natively integrates into all the just mentioned services. And we're very excited, Marco, to already talk with your teams about GPT-4o, the real Omni model. Very excited to get first glimpse of that as well.
Oh, again. All right, so now you have a whole bunch of different customers that are using this stuff. And you've built this copilot. How do you test it? How do you evaluate it? How do you make sure that it's actually working for each one of your customers, that it's not hallucinating, that it's doing it right?
Yeah. So testing for AI agents and copilots is as important as doing testing for software development. So we are doing different things there. First, we are doing end-to-end load testing of the infrastructure, but also for the large language model. And when doing that, we also figured out that, especially at the beginning, we had problems with latency. So when there was globally a huge workload for GPT, we had sometimes latencies of 20 seconds, which is not really working in a production environment, right? So we switched to PTUs, and now it's working well, very, very constantly when it comes to the latency.
Right, so a PTU, a provision throughput unit, is a unit that you can buy that basically dedicates capacity for you in Azure OpenAI so that you get this dedicated throughput.
So we have a constant latency there. Then we're benchmarking our translation and transcription capabilities with our own audio data set to always guarantee in all the different languages the right quality. And finally, we build our own evaluation and simulation framework, which continuously tests the model, the prompting, the parameters, the knowledge against certain predefined goals to see if the outcome, if we changed something, is still the same. So it's large-scale testing of copilots and AI agents. You can compare it a bit like regression testing in software development.
All right. So now all the rage here at Build lately, if you've been paying attention, is about AI agents. Now, how are you folks thinking about using AI agents to assist the contact center agents?
Yeah, so first of all, we're living in an exciting time, right? We see AI agents getting smarter, more natural, more reliable. We believe that AI agents will take over more and more of the very repetitive tasks of customer support without the need of a human agent, so that human agents can focus on the very relevant, high complex and emotional tasks. And we also believe that AI agents will be a competitive advantage in the future because they will be 24/7 available, they're instant, they can be very personal. And if we go one step further, and Marco, let's assume you want to move to a new place and you want to change your address. Do you want to log into 20 different apps and log in or self-service portals where you might have forgotten your password or your email address you used, or call 20 different companies? Just assume you would ask your digital assistant to change your address on your behalf, and then your digital assistant starts doing it for you. And what is the most natural interface? It's a conversation we're having here right now. So the digital assistant would call or chat with all the companies and would change the address for you. If that happens, call and chat volume in customer support will explode, and companies will need AI agents as a support even more as now to support all the humans in customer support. So exciting times we're having right now.
Absolutely. Well, thank you very much, and keep up the good work over there.
Thanks,
I
Marco.
look forward to working with you further.
Thanks.
All right. Thank you, Malte, from Parloa. All right. And so now we're going to have a look at the tools that we've been building that we are giving to you to be able to build your own copilots, test them, evaluate them, trace them, and so on. So let me get past this slide here. All right. And now I would like to bring to the stage my colleagues, Jeff Omhover and Sindhura Bandhakavi. Jeff, Sindhura.
Thank you, Marco. So indeed, at Microsoft, we have been at the front of infusing AI into our own products. So we have been developing Copilot for quite a while, but we also have been working with external customers for them to infuse AI into their own product. So we're starting to see emerging trends in how to benefit and how to harness that technology into product development, and in particular, how to bring those product developments to production. And that's what we're going to be showing in the next 30 minutes. I'm Jeff Omhover. I'm a principal product manager. I was, for the last 20 years, working as a machine learning scientist, and I developed Copilots at Microsoft as well.
Hi, everyone. My name is Sindhura Bandhakavi. I'm an engineer with over 20 years of experience in shipping services to production. Currently, I'm an engineering manager on Azure AI Studio. I'd like to start, the next slide, please, thank you. I'd like to start with sharing the design principles that we have been using when building Azure AI Studio and how that relates to you. Our goal is to bring you stability in this world of continuous change so you can innovate with AI. The way we are doing that is firstly with our model catalog. If you're looking for a model, you will find it on Azure. Microsoft's strength in forging relationships and creating better together stories with our partners has enabled us to bring you the frontier models onto our platform at the same time as they are launched on our partners' platform. Secondly, our inferencing and fine-tuning as APIs are consistent across all models, regardless of the origin, as we bring you the models' APIs as serverless endpoints. These two are important because by the time you go from prototype to production, there will be a better model, a cheaper and a faster model. And we want you to be able to leverage those models in your application without having to change your code much. Secondly, responsible AI. If you have seen the breakout session by Sarah and Marnoosh, they went deep into why this is such a complicated subject. Generative AI applications have an attack surface which is very different from the attack surface of the traditional applications. It takes continuous research and new methodologies that Microsoft is bringing to you, the responsible AI tools and practices that we use to protect our copilots. We are bringing them to you through our tools. So one, any model on Azure as soon as it's available. Two, safety by default. Now, in this changing world, there are two things that are constant. One, developers live in code. And two, admins need to protect their company's resources and assets. For the first one, the tools that we are bringing to you are as SDKs that you can use in VS Code or an editor of your choice. For the second one, the AI Hub and project help admins to secure resources on the hub and add policies and governance on top of the hub, while the data scientists and the developers work on the projects. With those fundamentals, let's move to how you can build your custom copilots. When you're building your copilot, you start with the scenario. What is the problem you're trying to solve? Are you building an onboarding buddy for your new hires on top of company documentation? Or are you building an agent that does multiple tasks, like Parloa was showing earlier? It was doing translation, transcription, intent detection, entity identification, calling APIs in the background. All of these tasks bringing together. Regardless of what your scenario is, you first start with a prototype. And when you're doing a prototype for your orchestration, you can start with any of the GitHub repos we have shared with you during this build session, and they're also available in our Learn documentation and on ai.azure.com. Once you have your orchestration, you use draft prompts. And for evaluation, when you're prototyping, you might take your application and share it with your colleagues and just ask them what's working, what's not working. You are doing anecdotal evaluation. In prototyping stage, performance versus cost is not a consideration. You should take the best model available because you're trying to figure out if that scenario is feasible or not. Lastly, for compliance, use public data or non-PII data at this stage. Now, when you're going towards production, there are so many more questions you need to answer. What is the right application pattern? Is it RAG? Is it multi-agent agents? Or is it somewhere in between? Which model should you be using? How do you optimize for latency? How do you support safety? The good news is you don't need to answer all of these questions at once. In this session, Jeff and I are going to go through each of these sections: orchestration, evaluation, performance versus cost trade-offs, and compliance, and talk to you what approach you should be taking, what challenges you might be facing, and the lessons we've learned. So let's start with orchestration. Our lesson, embrace experimentation. Let's look at the system design from system design perspective. Your user is talking to your web application in natural language. In order for the bot to respond to the user, it needs a lot of information. And this information could be in the form of raw data, whether unstructured, like documentations or PDFs, or structured data, like SQL. or it could be APIs from your microservices. The core part that brings these two pieces together is the core part of the agent architecture. We are going to go through each of these components in detail. Jeff is going to take us through that, starting with a demo.
Absolutely. So as we reference this template architecture, we want to kind of like deep dive into how that will work in practice, right? So we usually start with code, right? So that's the first thing we do. And here we have an example that is available online, and that's already in the chat if you want a reference for it. And that's a code template when we have tried to put that architecture into practice. So I'm typically in VS Code. I'm having my basic chat completion function. And here we want to emphasize how our current Azure AI Studio and its related SDK just take you wherever you are. I'm just packaging my code within a chat completion function, whatever that code is. In that example, I'm going to use the Azure OpenAI Assistance API for running an agent, right? So I'm doing all sorts of different things. I'm doing like logging for different events. I'm loading for a configuration. What I mean by my configuration is all the different settings that my system will have to use at any point of time during the exercise of the architecture itself. Then I'm having like a session manager and all those different aspects, which is basically handling the conversation and then orchestrating, figuring out what to do about the intent of the users and how to respond to it, etc. Let's show it in practice instead. So once we have that code, I can use here the prompt flow test bed, the local test bed, to actually try my code live. So I didn't design that UI. I'm just using that UI from prompt flow test bed directly, and I'm going to be able to ask it queries right away, right? So I already asked a query just to show you what that application is about. So as Sindhura mentioned, we are doing here a SQL data analytics example. So we're asking what are the average sales in January, and then the system is coming back to us with an answer in natural language, right? And to do that, it's going to perform all the actions of like figuring out which SQL query to ask my SQL server and get the results back and format it not as like a table, but like as natural language, right? But I can also like ask a more complicated question, like, can you plot the total sales per product type? And then the agent is going to kick in and try to figure out what to do about it. So let's look at the trace of that event, right? So we're going to have all the different cascade of actions happening under the hood within that agent architecture. So the first thing, of course, is to get like an Azure OpenAI client, right? And then we do a session management. We record we get the session that was a session in the previous history, sorry. We get the session, which is the history of conversation before the current message. We record a message within that thread, right? So let me actually enhance a little bit. Yeah. So we record the last query of the users, and then the orchestrator kicks in. And the orchestrator is going to loop and try to figure out, OK, iteratively, what should I do about this to resolve the intent of the user? At some point in time, what the orchestrator would do is detect that it needs to execute a particular extension. It needs to evoke a particular extension. So here, in the case of my demo, that extension is a SQL query. So it's going to just query the order data. And here, in my demonstration, I just fed a Python function that calls the SQL query. Like that's it. So the SQL query has been designed by the assistant itself, right? I didn't write that. It came up with it. And then the results are coming back from the SQL server. And the results are going to be sent back to the orchestrator loop for the orchestrator to figure out what to do about it. And what to do about it is to actually create a graph with it. So I can here directly debug what the graph is going to look like, and then some message that comes with it, like here's a bar chart showing the total sales for each product, et cetera, et cetera. So all in all, every aspect of the architecture is going to be put into motion for first figuring out how to handle the history, then what to do about it, orchestrating the flow, calling the extensions, and getting back to the users, right? So as I mentioned, we have on one side the user-facing application, session management, orchestration, planning and execution of actions, planning and execution of extensions, and then the extensions themselves. In the context of my demonstration, the extension was just a SQL server. But you could imagine having RAG on search as an extension. I would look for information into that particular database. Or you could have any kind of API whatsoever, like an internal API for finding out information about the user or validating a particular user ID, for instance. One of the things that we mentioned at the beginning of this key lesson is embrace experimentation. And the reason is every single piece of that architecture will be iterated about 100 times. What we mean by that, usually the first thing that comes to mind is prompt engineering, right? So you're going to be doing a lot of iterations on what is the best prompt in order to detect the intent of the user, extract it from the conversation, and then plan for the next action, figure out how to summarize the answer and send it back to the users. And then can be multiple strategies going on here. But we could also think about search itself. Search is going to be the object of intense experimentation for figuring out not only the search parameters, but also the indexing configuration. What embedding should I use? What chunking strategy? What metadata should I extract? Et cetera, et cetera. And if we even look at the session itself and the conversation itself, you're going to have even more parameter there. So what is the length of the conversation we should take in and we should digest within that system? Should we record all of it, or should we record only the recent one? Should we do RAG on that? Should we retrieve relevant passages from history? And on safety configuration side, what threshold should I apply to make sure that my agent is not going to be outputting harmful content? So every piece of that architecture is going to be iterated about, and you're going to need to be able to embrace that within your designs.
So the interesting thing here, Jeff, if you go back, if I were to write a REST API or a traditional application, the way I would do that is I would need to know every scenario that the user might be calling, and then I need to code it explicitly as to which sprox it will refer to, and then validate it and test it, right? So here, without knowing exactly what the user questions are going to be, the agent is taking care of all the orchestration. But then the challenge is there are so many different parameters, and a slight change of one parameter is going to change the complete behavior, and you want to be able to control it.
Absolutely. Which brings us to our key lesson, which is how to embrace all of that.
Yeah, so we just saw, just to internalize what Jeff showed us, not only did my beautifully crafted REST API with HTTP status codes that tell me whether a request was success or failure got completely replaced with English, then there are so many permutations of parameters that can change the behavior of the system. And in such a non-deterministic system, how do you test? And more importantly, how do you prevent regressions?
Absolutely. So that's going to be the object of our second session, which is how do we make sure that we can, now that we build an experimentation tool and we can hot swap different parameters and different components, how do we build an evaluation process that we can trust to make sure that we actually enhance and optimize for quality? And our key lesson is invest in comprehensive evaluation data. So let's go back to the architecture schema. Usually, when we think of quality, we usually think about the end user perceived quality, right? And so here, the metrics are usually becoming more and more standard nowadays, which are evaluating the completion quality in terms of groundedness, relevance, coherence, fluency, et cetera, et cetera. And we have tools for that, and we're going to be talking about them, right? But each piece of that architecture will actually need to be evaluated on its own. For instance, if we're talking about the orchestrator itself accomplishes a very complex task, which is understanding the intent and executing the right action. And that task has a metric, that's accuracy. Like, what is it? Do we actually map the user intent to the right function? If we have just one, that's an easy case. If we have 100 of them, that's becoming a really hard case to solve. So you're going to be needing to do a lot of experimentation there, and you need to measure accuracy in itself. Retrieval as well has its own metric. There was an entire breakout, BRK145, about RAG at scale, where basically you also need to embrace how to experiment for maximizing recall, precision, and latency, right? Which is a problem in and of its own. And naturally, the completion is also going to need to be related to safety metrics, right? So making sure that the content that is going to be outputted by the agent is going to stay not harmful and not hateful and not violent, etc. And the key metrics of all, latency, is also going to be part of your evaluation metrics. So every component must be associated with its key metrics and probably also with its key data sets, right? So before we deep dive into the data set, let me explain to you a little bit how Azure AI Studio can help with the evaluation. So if I look at this agent that we designed pretty quickly as a proof of concept, if we want to evaluate that agent, what we can do is we can leverage the evaluation SDK. And what the evaluation SDK does is just giving my completion function in Python, giving me an evaluation data set, and running a set of metrics or a set of evaluators on top of it. And those evaluators are classes in our SDK that you can just pull in depending on what use case you're going to have, right? And everything here is done in code. And the value of that is you're also going to be able to add it to a CI/CD pipeline. So for instance, every time somebody is going to create a branch and is going to want to try out a new version of a prompt or modify a little bit of a configuration, you can automatically evaluate that pull request, create a GitHub action, create a DevOps pipeline, and link into and produce a particular scorecard, right? So being able to do evaluation from code is going to be critical to have a DevOps-centric practice on shipping new features and new versions of your model. So here, in that example, I'm having evaluation data sets that I'm using locally. What we mean by that is a couple of sample queries, right? We can have multiple of them. A couple of sample queries that I'm running, and I have the actual ground truth, quote unquote, which is the expert opinion, the expert answer for that system, right? So in the Azure AI Studio SDK, once I run that evaluation loop, I'm going to get all my results into that studio so I can actually share it with my team and review it, not just me, my developer, but also with UX experts and everybody else involved, right? So here we look at the typical metrics that will be adapted for my particular use case. So in the case of that SQL analytics agent, we don't really have context, so groundedness doesn't really come into play. But if we had RAG, we could pull in groundedness. What we have here is coherence, fluency, and similarity. Similarity in particular, because that's the relationship between the ground truth answer and the reply of my agent, right? But coherence could be important as well, which is how much the answer actually relates to the question that was asked, right? So in that example, I can use that UI to find out what are the best possible examples, which are great because then I can show them on stage at build, right? But I can also look at the worst possible example. What's happening for the worst case scenario? Well, sometimes my assistant doesn't reply. Maybe it thought that the question was out of scope and not the question it should answer, right? Which brings us to an interesting evaluation you should actually do, which is let's try to evaluate and to make our system answer really badly on specific questions. Here I'm having an evaluation where my agent is failing really hard. It's failing so bad. And the reason is actually it's a good thing, because in that case, I'm asking a lot of questions about cats, right? And I don't want my system to answer those. But here, by having that data set of questions about cats or anything else you could think of, or even maybe harmful questions, or tricky questions, or jailbreak questions, I can make sure that my system does not answer those questions. How do we come up with those? Well, several ways. There is a hacky, super simple way, which is you go in a playground and you just ask a random model to ask that one. I just did that this morning. Can you generate 20 random questions about cat and format it this way? And you copy-paste that, and you put that in VS Code, and you're done. That's easy. But there is a more thorough simulator SDK you can use to generate that at scale, or maybe depending on the topic you want to generate. And you can also use that Pirate SDK we've seen to generate adversarial prompts and test out your model against everything. So all of those data sets are going to be part of a comprehensive evaluation you're going to need to put out.
Can I ask you a question?
Please go ahead.
So here you're creating negative data set.
Yeah.
Right? So how do you prevent your LLM to not respond to that? Do you have to have this programmed in the LLM?
That's the difficulty, which is the LLM itself is going to need to have a way to figure out the intent and what is in domain and out of domain, right? And that's the object of intense prompt engineering. And sometimes you're going to have to deal with trade-off, which brings us to this question of the scorecard and how you can leverage those data sets. Because, for instance, in some of our own internal projects, right, you try to think about, OK, how do I address those cases where the agent said, oh, I don't know, I don't have a reply to a question it should have, and the natural reflex is like, I'm going to do a different prompt. I'm going to try to maybe do a different wording on what is in domain in my agent, and then it suddenly answers those questions, but then it suddenly starts answering questions about cats or dogs or Michael Jordan or whatever, like anything else, right? We had those examples internally in the team. And so that's where you're going to have to trade off, and you're going to have to figure out how do I actually really optimize for all those metrics, not just one. And so here I laid out a couple of example data sets that we use in our own example internal copilots. So the hard one is like qualified answers, which is the ground truth. I have an answer, I have the authoritative, I have a question, I have the authoritative answer to it, and I'm going to see if my model is comparing well to that. But I can also have like synthetic examples, and those could be a good complementary approach, especially if you want to evaluate planning metrics or retrieval metrics, right? And then out-of-domain questions, we talked about that, adversarial questions, which are tricks to try to trick my model to answer harmful content. We could also think about thumbs down, right? Like we had this thing internally in the team where people were reporting, oh, the model actually said that to me. I think that's the wrong answer. For instance, somebody from UX or a PM testing it and saying, I don't think that's the right answer for that. And that's a great collection to build, because then as a team, you can start to discuss, hey, should our model really answer this or not? How do we achieve that? And that's a really powerful thing to do, especially for increasing quality. And at some point, you're going to have production data that you will have to scrub in order to make it compliant and use that for monitoring as well, right? So all of that brings us to this key lesson.
Yeah. The key lesson during evaluation is invest in comprehensive evaluation data. You want to start with a small set of authoritative data, probably collated from your SMEs. But then you want to multiply those evaluation data sets, use hitting all the parameters and all the dimensions that Jeff talked about. A couple of things I want to highlight in the two of Jeff's demos. If we did not have the prompt flow tracing SDK, then we would not have a window into what the agent was looking at. Then second, the evaluator SDK that you showed, it was bringing data science metrics and calculating that automatically for me. So for someone like me who is an engineer who does not really understand them, I can leverage the evaluator SDK. And in one of the sessions that Sarah and Marnoush did on responsible AI, they also showed you how you can build your own custom evaluators. So you can define what your metric is going to be for your business and use that via evaluator SDK in your CI/CD pipeline for offline evaluation or online, as we will get into. Second, associate each data set with its own metrics. We talked about that. And most important, when you have all of this, run it against every iteration. Every PR that is getting checked in and making changes to those parameters, you want to run your evaluation SDK on it and check what's happening with the metrics. And we had a great session on LLM Ops yesterday, BRK110, in which Dan and Cassie went deep into details along with a fully working GitHub repo that you can use for orchestrating the agents. It was called Creative Writing Assistant. Please check it out. It's recorded. And finally, review results as a team. This team aspect is super important, even during experimentation and while evaluation, especially since there is no binary answers, right?
Yep.
And for experimentation, I have a call out to the leaders and managers in this room. You need to give space to your engineers and to your team in order to experiment in low-stakes environments. Maybe they are building tools for their own engineering productivity, so they are ready for you when you need them to build AI tools for your production environment and for your customer and business scenarios. So with that, thank you. So Jeff has written a beautiful prototype. We made sure the system works. We've componentized it. We are testing it. We have the evaluation data set. We are taking it to production. What can go wrong? Our lesson in production is nothing new to us. Measure, monitor, and tune for quality, latency, and cost. Now, going back to our REST API world, we know how to track reliability and latency. We have our SLA, SLO targets. We have our beautiful live-side dashboards that show red and green. And we know how to drive the error rate down. But with natural language, where there is no binary answer, this gets tricky, right? So to start with, you can start with your customer signals. For example, the upward, downward button that Jeff was talking about. And in case of Parloa, so customer service agent, it could be customer CSAT, it could be agent CSAT, it could be the total number of percentage of closed cases, or the cases that have been escalated into manual evaluation, right? So those are your business metrics. You want to think about them, you want to measure them, and more importantly, when you're making any changes, you want to do those as an A/B experiment, checking that your business metrics are going in the right trend before you expand it out. So these are typical engineering practices, except that they become more important in Gen AI development and taking them to production. Now, if we put the business metrics aside, let's think about system metrics. So before we get into system metrics, remember the tracing library, the prompt SDK's tracing library that Jeff was using? I want to see what it is logging. So if you notice, this is the OpenAI chat LLM. Basically, each of the nodes on the left are the function calls, on top of which we added a decorator @trace, and the prompt flow SDK is automatically logging some data. And the raw JSON that you see is in the OpenTelemetry, the standard OpenTelemetry schema. Why is this important? It's important because now you can pipe the information into any OpenTelemetry compatible logging, like App Insights, and then use Azure Monitor to build your live-side dashboards. So looking deeply into what is getting tracked, which are important for our quality, latency, cost metrics, it has start time and end time that talks about that gives us latency. It has LLM usage, completion tokens, prompt tokens, and total tokens. And as you all know, tokens are important for cost. Understanding your token usage helps you optimize for the cost of your application. This prompt flow SDK is also logging all the inputs and the outputs. Now, in a typical REST API application, there is really no reason to log your HTTP response, especially a successful one. You log the HTTP status scores, you log the error codes, you log the stack traces, and that's enough for you to debug your application. But in generative AI, some scenarios, you might have to log the inputs and outputs. And when you do that, do so extremely cautiously. Do your privacy reviews. Those become even more important in Gen AI application. And second, if you can, where you can, get your user consent. And thirdly, do PII redaction before logging. And I want to share with you a tool we have in Azure AI for that, an API, exactly for that. You know, when you create the AI Studio Azure AI Hub, along with all the frontier models and the SLM 5.3 models that we talk about, we also give you AI services that are in speech, vision, document intelligence, and language and content safety scenarios. I want to go into the language. And if you notice, we have something called an API for PII detection and redact personal identifiable information. Let's take a look at a sample. In this sample, you see there is some text, legal text, with some personally identifiable information. The API is able to identify and tag them. If I look at the JSON that's retrieved by the API, you can see the redacted text and the entities that were identified. So you can use this API in order to redact PII information from your requests and responses before you log them. Now, assume that we've followed all the good practices that we should be following in production and logging the right data. Then we can get our token usage, generational quality, and operational metrics. What I'm showing you here is I deployed my application as a managed endpoint in Azure AI Studio. What that gives me is, by default, it is tracing sample data and then running the evaluator SDK once a day in order to generate all of these metrics and showing it to me in a dashboard. So I have token usage, generation quality, which are same as the coherence, relevance, fluency, groundedness scores that we were seeing earlier in offline experimentation. And then we also have the operational latencies. Jeff, can you take with us what is special about LLMs and latency?
Yep. So that notion of latency is going to be also very critical in Gen AI applications, because those models will have different capabilities, but also because the system is actually a pretty complex piece of architecture, and every piece will come into play, right? So each component will come with its own challenges and its own opportunities. So usually when we think about latency, we think about like the user-facing latency, right? And that's the completion one, the completion latency. And that's because that's where the clock starts and that's where the clock ends for the end users, right, of the product. But within that latency, we're going to be able to identify a critical path on which every single component is going to come into play. So for instance, the orchestrator itself, which is detecting the user intent and planning for extension or actions, that's going to be directly on the critical path. Nothing will happen unless this thing knows what to do with it. And so that's going to be some really heavy piece of that, heavy chunk of that latency. And if we're using retrieval, no answer will be provided unless we actually retrieve the document. So that's also going to be on the critical path of latency. And so all those pieces will actually need to call for different strategies for optimization. So, for instance, if we're talking about the orchestrator, right, which is just doing that very single task, well-defined task of understanding intent and linking to action, that's a good candidate for figuring out a good prompt compression technique, right? Or maybe using a smaller language model just for executing actions faster. If we're talking about retrieval, the whole breakout session 108 had like many recipes for like how do we do scalable search, how we do fast model embeddings and caching, right? And the completion itself can be a funny game of like latency trick, which is where first thing, figuring out how to optimize for the latency of the first token, the first word that comes out of the agent, right, in order to let the user wait or set expectations with the users. And there can be creative experiences you can design there to also help alleviate or mitigate that latency. For instance, saying, oh, I'm doing this action, I'm calling that server, I'm thinking about the next thing to do. And that could be also helping with that. So all of those different parts will be helpful. Figuring out where those parts are will be helpful to know which strategy to employ and what would be the benefits of it. Which brings us back to this notion about embracing experimentation and having robust evaluation. So it's really, everything goes in a loop.
We wanted to leave with you a reference architecture diagram that shows you all the components in production. And then this is a typical Azure topology with Azure AI hubs and projects in managed VNet. The key lesson in production was measure, monitor, and tune, and handle workload spikes with hybrid PTUs for sustained load and pay-go for variable workload to manage your costs. To conclude, this is the future. Every application is going to be an AI application. So if you haven't started yet, you should now. And hopefully, we have shown that this is a tractable problem. Second, we are in here with you in this journey. As models change, we will get them to you. As agentic patterns change, we will get the SDKs to you where you are, and you can build it on a responsible AI way on an enterprise-grade platform. Thank you.
All right, Sindhura, Jeff, thank you very much.
Thank you.
Unfortunately, no time for questions, but we'll be sticking around over there to answer any questions that you might have. Thank you all, and have a great build.